welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 23 from the practice paper for the new IGCSE 0580 paper 2 non-calculator paper. This is a practice paper put out by the examining board to give us an idea of the type of questions that could come up. So here we're asked to rationalize the denominator. Rationalize the denominator. Now, when you rationalize the denominator, okay, you want to make the denominator into a rational number. Okay, so in order to make the denominator a rational number, you have to get rid of any square roots, because a rational number, a number which is rational, has no square roots of square roots of non-square numbers associated with it. So this has a square root of a non-square number, so it's considered irrational. We have to rationalize it. So what we're going to do is we're going to take this fraction, 45 over root 6 plus 1, and we're going to multiply both the denominator and the numerator by something that will get, well, first of all, let's think about the denominator. We're going to multiply the denominator by something which will get rid of this root 6, to get rid of the square roots. So basically, from the concept of the difference of squares, if I multiply it by root 6 minus 1, which is called its conjugate, then what's going to happen is you're going to have the middle term will be the only thing with square root in it, because root 6 times root 6 will give you 6. You have minus root 6 and you have plus root 6, and then you have minus 1. Well, minus root 6 plus root 6, they cancel each other out. So whenever you multiply something like this by its conjugate, by the thing which is the same numbers but the opposite sign between them, the middle term will disappear. So it's based upon the whole concept of difference of squares, where the middle term disappears. So in this case, this will give us a rational denominator. But now, this fraction is not the same as this fraction, okay, the way it's written now. So what we have to do is make sure that this equal sign makes sense by multiplying the numerator by exactly the same thing that we multiplied the denominator. Now the fractions are equal, so this will be equal to what this comes out as. They'll have the same value, just they'll look different. Just like if I have a half and I make it into another fraction, like for example 3 over 6, it's like I've multiplied both the numerator and the denominator by the same thing. So these two fractions have the same value, but they just look different. So this and the answer will have the same value, but they will just look different. That's all. Okay, so this is going to be 45 times root 6 minus 1 over, and here we're going to have root 6 times root 6, as I said, which is 6, and you're going to have minus 1, because the middle term will disappear. Now, supposing it was, for example, something like 2 over root 3. How would we rationalize the denominator? Well, this is even easier. You don't have like a combination of a rational and irrational together. Here you just have to multiply the denominator by itself. Root 3 times root 3 is 3. But then you also multiply the numerator by root 3. So you have 2 root 3 over 3, and you've rationalized the denominator. Okay, so that's how it would be if it was just one term. But in this case, it's not. So in this case, you have two terms, and between them, you just change the sign. Multiply by the opposite. If it was root 6 minus 1, I'd multiply by root 6 plus 1. Root 6 plus 1, I multiply by root 6 minus 1. So now I can try to simplify this. So 45 times, I'll leave it like this for now, because I can see something which will help me to make it simpler. There's a 5 under here, right? So I can cancel this 5 with the 45, gives me 9. So I'm now left with 9 root 6 minus 9. Okay, I guess I could even write it as 9 root 6 minus 1. That would also be acceptable, but both of them are fine. So I'll just write it as 9 root 6 minus 9. And there's the answer to question number 23. Okay, so that's rationalizing the denominator and giving the answer in its simplest form. So other questions from this particular paper you'll find in the playlist on the top right of the screen at the end of this video. Other questions from the topic of surds and manipulating and simplifying surds, you find in the playlist on the bottom right of the screen. My arithmetic topics from the new syllabus, you find them in this playlist, and you can subscribe to my channel by clicking on the link at the top. Thank you for watching, and see you soon.